All right, we're going to continue looking at polynomial functions. We're going to specifically talk about the end behavior of a polynomial function. So I'm going to draw a graph, and then we're going to go through it, and we're going to state the degree, the leading coefficient. We're going to talk about what end behavior is, and then we're going to state the domain and range for the function. So the first one that I'm going to draw in is a parabola. I'm going to try to make it symmetric. There we go. So this is going to be our parent quadratic function. So it goes through the origin. It's the most basic quadratic function. There's no shifts left, right. There's no flips up or down. This is our parent function for a quadratic function. Now I'm going to go through and we're going to label these things. So let's start with the degree. The degree is your highest exponent. So we know this is a parabola. So my degree is 2. The leading coefficient, I want to know the sign of the leading coefficient, like if it's positive or if it's negative. Well, this parabola is going up, so it's positive. So the number that's in the front here, even if I did not have this equation here, it would be positive. I'm going to come back to end behavior in just a minute. I'm going to jump down to domain and range. This is a parabola. All parabolas, the domain is all real numbers. So that was from a little bit ago. And if you wrote it in set notation, I'm okay with you saying negative infinity to positive infinity. So these two say the same thing. Domain for any parabola is all real numbers, or if you write it with the interval notation, is negative infinity to infinity. Now, the range is what's happening top bottom. It's your possible y values. This parabola does not get below this point right here. It does not get into -1, -2, -3. So my range is anything greater than or equal to 0. So whatever this minimum point would be, that would be your range. So domain and range is from a couple of weeks ago. Let's talk about end behavior. End behavior is the new piece for today. End behavior is what is happening on the left side of your function and what's happening on the right side of your function. So end behavior. As x approaches negative infinity. So this means as your x values get smaller and smaller and smaller, what is happening to your y value? That's what that question is asking us. Down here at the bottom, as x approaches positive infinity, this is as your x's get bigger and bigger and bigger, what's happening to your y values. So again, this arrow means approaches negative infinity. This arrow approaches positive infinity. And f of x is your function, but you always can replace that with y. So this one says as x approaches negative infinity. That's this section down here on the graph. As x's get smaller and smaller, that's on the left side of our graph. So I'm going to label this left side. So what is happening on the left side? My function is going up. So my function is approaching positive infinity. So I put positive infinity there. So as x approaches positive infinity, or in simpler terms, what happens is my x values get bigger and bigger and bigger. While on the right side here, my function is going up. So it is approaching positive infinity. So we filled in everything for our first graph. All right, let's jump down. I'm going to take a look at number 2. I'm going to draw a different graph in here this time. This time, I'm going to make the parabola flip upside down. So I'm going to make it go this direction. Okay, so this one's going upside down. So my equation for this is the following. So f of x equals negative x squared. We're going to go through and we're going to label all the things we did with the first one. Your degree is your highest exponent. So I have a degree of 2 because it's parabola. Leading coefficient, I want to know the sign of the parabola. And another way you can know, even if I do not give you the equation, if it's going down, it has a negative sign. If it's going up, it has a positive sign. And you read from left to right, so you will be referencing the right side of your graph. But since I do have an equation, it's negative here, it's going to be negative here. Okay, we'll come back to end behavior. We got domain and range. Domain for all parabolas is all real numbers. Or in set notation, it'd be negative infinity to infinity. And your range, this graph does not get above this point right here. So it's from this point down. So it's anything less than or equal to 0. Now let's talk about end behavior again. So what's happening as x approaches negative infinity, that's the left side of your graph, what's happening. And as x approaches positive infinity, what's happening. So the left side of my graph is the negative, and the right side of my graph is positive. So let's take a look at my graph. So as x approaches negative infinity, so that's going to be down here where I'm going to point. So as your x values get smaller and smaller and smaller and smaller, what's happening to your y? It's going down. The second part says as x approaches positive infinity, so as your x values get bigger and bigger and bigger on the right-hand side, what's happening to your graph? So both of these, my end behavior is going down. So it'll be negative infinity, negative infinity. So let me zoom out so we can see all of that all at one time. So in behavior, as x approaches negative infinity, my function approaches negative infinity. As x approaches positive infinity, my function approaches negative infinity. So both of these graphs, both sides of this is going down. So my end behavior was going down for both of these. And if I go back and look at number 1, my end behavior is going up for both of these. Now let's take a look at a different function. We've been looking at quadratics. Let's take a look at what a cubic one would look like. So I'm going to draw a cubic function into here, and then we'll go through and label everything in the cubic function. So I'm going to say it goes like this. Okay. So I just drew in a regular cubic function. So a cubic function can go up, or down, up, down. So the equation for this is x to the third. All right, your degree, highest exponent, 3. I can see that from my equation, and I also can see it from the shape of my graph. The leading coefficient is a positive because on the right-hand side it's going up, so it's a positive leading coefficient. End behavior, what's happening on the left side of your graph. This is the left side of my graph. It's going down, so my end behavior is negative infinity. As x approaches positive infinity, what's happening? So again, this is the right side of your graph. What's happening on the right side of my graph? This graph is going up, so that's positive. My domain and range are both the same. For cubic functions, your domain and range is all real numbers. And we'll take a look at one more. So this is a cubic function. I'm actually going to make the cubic function flip in the other direction so that it's negative. So this one's going to be going the other direction, so I'll draw that in. It's going to look something like this. And we'll go through and label the different characteristics. So this one is negative x to the third. All right. The degree is your highest exponent. I can see that my highest exponent is 3. It's cubic. Your leading coefficient, what's the sign in front of the leading term? It's a negative. So this is going to be negative. End behavior. As x approaches negative infinity, that's the left-hand side of your graph. So what's happening on the left side of my graph is going up. So my function is approaching positive infinity. As x approaches positive infinity, what's happening? This is the right-hand side of my graph is going down. So we'll say negative infinity. Domain and range for cubic functions, both are all real numbers. So take home point for end behavior. You're going to look on the left-hand side and you're going to look on the right-hand side and see what is happening to your graph. As x approaches negative infinity, that's the left-hand side. As x approaches positive infinity, that's the right-hand side. And you'll put the infinity sign and tell if it's going up or tell if it's going down.